lecture 31. Okay. So today we'll start with changing the order of integration. Okay, so this is an important topic as I've already mentioned. Okay, so I'll note down few steps, that few points that you'll keep in mind. Okay, so first point is through a horizontal right to mark the enter and exit point. For the limits of x, or the x, I would say, right? Through a vertical line of course in the region, I would say that, okay, in the region, through a vertical line into the region to mark the enter and exit points for the y, right? So these are the two rules you will always keep in your mind. So let's say how we do it. Okay, so first of all, I'll start with an example which is already in the book, and then we'll move for the questions. So this is one example, example 4. And that's what, sketch the region. And see, this is the standard form of the question. That's how it is asked, that sketch the region, and after sketching that, change the order of the limits. Okay, somebody was asking why we put it dx first, why cannot we dy? So we're gonna solve all those questions. So first of all, you know that it's dy and it's dx. Okay, so these are the limits of y and these are the limits of x. So you need to plot only region. You don't need to make a 3D plot of all that. Okay, so let's say mark the region first. So if your x is 0 somewhere here and x is, let's say, 2 somewhere here, right? And what is y is equal to x square? Tell me.
Parabola.
Yeah, so somewhere here, let's say 4. Okay, when you put x is equal to 2, this will become what? 4, right? So let's say over here. Yes, you are with me?
Yes, sir.
So this is your parabola. Let me complete this. So this is your parabola, y is equal to x square. And this point is 2 and 4. And what is our second line? That is y is equal to 2x. Okay. So if you put x is equal to 2 in this equation, y will also be 4. That means y is equal to 2x will be a line which will also pass through this point, right?
Yes, sir.
Yes, you are with me? Okay. Yes, tell me. So yes, this sir. Is your line y is equal to 2x. So can you see the region?
Yes, sir.
Yes, sir.
So
Yes, sir.
this is the region, right? That is enclosed between the parabola and the line. Yeah. You with me?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. See, one of your limit is always constant. Either y's limits are constant, either or x will be the constant. Okay. Now you think that you want to change it, right? So you want to change it. That means you want to express x in terms of y, and you want to keep your y constant. Okay. Is it fine? Are you with me on this?
Yes, sir.
Yes. So let me just drag this graph a little downward just to make the things clear. Yes. And then let me make like this. Oh. Yeah. Right. So can you tell me what are the constant limits of x over here? Yes. Can
Between
you tell
0
me?
and 2.
Yes. Yes. From 0 to 2. Okay. But if you see in those limits, y is varying from where to where? From here to here. Y is not constant, right? So lower limit of y is on the parabola and upper limit of y is on the straight line. Yeah. Am I right?
Yes, sir.
Yes. So how you can check this? You simply throw a vertical line into that, you'll come to know this. So you throw a vertical line. So mark the entering and the exit point. What is the entering point? The lower limit, right? This is your
Yes, sir.
entering point. And what is your exit point? Can anybody tell me? This is your exit point. Right? Is it okay? This is enter and this is what? Exit. So of course your y is varying, right? So that means this picture tells us the whole story that all these things are right. Yes, that means this is your y limits, right? And this is your x limits. So everything is fine. Now we want to change it. That means instead of x, we want to keep our y constant, right? So how are we going to do it? So for x, we need to throw a horizontal line into that. Okay. And we'll keep y constant. So first of all, if you want to take the y stretch constant, that means, see, you check the whole thing that your y starts from 0 and goes to 4, right? These are the possible ranges of y. Okay. But here, if you throw a horizontal line into that, okay, let's say you throw a horizontal line into that. So where are the possible entrance and exit? Can you tell me? Can you mark where is the possible entrance and exit?
Upper limit on parabola.
Entrance कहाँ पे है?
Sir, line.
Straight line.
Yes. Yes. This is your entrance, right? And this is your exit. Okay. Every time is it same? Tell me.
Yes, sir.
This is entrance and this is your exit point, right? So when you go horizontally, so that means this is your this is your entrance and this is your exit. So once you know it, everything is done. That it's that simple. Okay. So now you change your limits. You will write it as y runs from 0 to 4 and x runs from, see, you have picked the horizontal line, but here your x starts from line, equation of line. That's what y is equal to 2x. So from here your x is what? Y by 2, right? Because your x starts from the line, that's why. So your x starts from y by 2 to where? So your x end over here, right? So from here, this is parabola. And you know the equation of the parabola is what? Y is equal to x square. So this is your exit. So यहाँ से x की value क्या आ गई? Root y. Okay. So that means you goes to root y. And everything else will become same, right? It will remain same. So 4x plus 2 is as it is. Just you will replace that order. This order will get replaced. Okay. So earlier it was dy dx. Now it will become what? Dx and dy. Yeah, right? and these will give you the same answer. Is it okay? Yes, can you tell me?
Yes, sir.
Fine. Are you getting the point?
एक मिनट दोबारा बताना।
हाँ बोलो कहाँ पे?
से जो x की वैल्यूज आपने लिखी थी।
हाँ मैंने बोला यहां से हम x का एंटर और एग्जिट मार्क करते हैं, तो x का एंटर स्ट्रेट लाइन से है ना, और एग्जिट कहाँ पे है? पैराबोला पे। ठीक है, तो दोनों इक्वेशन से x की वैल्यू निकाल लो, दैट्स इट। तो लाइन से x की वैल्यू क्या निकली यहां से? y/2। ठीक है, और पैराबोला से x की वैल्यू क्या निकली? √y। और स्टार्टिंग वैल्यू क्या है? y/2। एंडिंग वैल्यू क्या है? √y। सो यू विल सिंपली से इट एज y/2 to √y। इज इट ओके?
सर वैल्यू तो वही सेम आएगी।
कौन से वाली?
इंटीग्रल की तो चेंज क्यों किया?
हाँ इंटीग्रल की वैल्यू सेम आएगी, इंटीग्रल की वैल्यू सेम आएगी। नाउ द क्वेश्चन अराइजेस दैट व्हाई वी आर डूइंग दिस। यस, इज इट राइट? व्हाई वी आर डूइंग दिस? तो उसका एक आंसर ये बनता है, हम कुछ क्वेश्चंस में देखेंगे कि अगर हम इंटीग्रेशन की लिमिट चेंज करते हैं तो क्वेश्चन बड़ा आसान हो जाता है, अदरवाइज जो क्वेश्चन है वो बड़ा टफ हो जाता है अगर हम ना चेंज करें तो। ठीक है, सो विल कम टू नो दैट। ओके, इज इट ओके?
Yes, sir.
यस
सर प्रीवियस स्लाइड दिखाना है।
यस।
तो सर हम बिना ग्राफ बनाए तो लिमिट चेंज नहीं कर सकते ना?
हाँ हाँ, रीजन हमें बनाना पड़ेगा, रीजन बनाओगे इट विल बी वेरी हेल्पफुल टू यू। ठीक है, yes, are you with me?
Yes, sir.
Okay, so should I move?
Yes, sir.
Yes, sir.
Okay, so let's start from a simple but very useful question. Okay, so right, so this is there. Question is, change the limit and then evaluate the integral. Right? Is it okay? So first of all, the thing which is given to you, first of all, you have to have a complete understanding of that. Right? तो पहले तो जो रीजन बना रहे हो, you are drawing the reason, you know the reason itself only. After that you can change the limits. Okay, as a now reason ही गलत plot कर दिया, then everything will be wrong. So let's say starting from, these are the limits of y or x, tell me.
Y.
Y.
Yeah. Yes. And these are of course the limits of x.
X.
Now these four things will help you in drawing the region, these four things. So let me pick this whole expression to the next page so that we can easily draw the region. Okay, so this is here. So we'll take our instruction from these four restrictions and then we'll construct the region. Now what is x is equal to 0? Tell me. Yes,
Y-axis.
y-axis. And what is x is equal to pi?
Line parallel to y-axis.
Yes, that's it. And this is your x is equal to pi. Yes, you are with me?
Yes,
so this
sir.
point is pi 0. And now we have next is y is equal to pi. So y is equal to pi means what? So a line which is parallel to the x-axis.
X-axis.
Yes. So this is your y is equal to pi. And of course, you know that this is the point which is pi and pi. Right? Yes, tell me.
Yes, sir.
And next is y is equal to x line. Right? So y is equal to x line is, of course, will pass through from here. Okay? Yes, tell me.
Yes, sir.
Now,
Yes, sir.
one possible confusion would be what? In selecting the region. That means either it is a green region or it is a red region. So which is the proper region for this integration?
So green.
Green. Why green?
was with respect to y-axis?
No, because our lower limit starts from y is equal to x and end at y is equal to pi. Right? समझ आ रही है ये बात? तो y यहां से स्टार्ट होके यहां तक जा रहा है. अगर y 0 से स्टार्ट होके y x तक जाता तो यहां से लेके यहां तक होता. समझ आ रही है बात? Are you getting my point?
Yes, sir.
Yes, sir.
So
Yes, sir.
our limit starts from this point, y is equal to x, and ends at this point. So that's why green is the actual reason. Okay? So where I put a green cross, that is the actual reason. Yes.
Excuse
Are you
me,
with
sir?
me? Yes.
सर मतलब हम y को देखकर रीजन मार्क करेंगे हम.
हाँ, सभी को, चारों को देखना है हमें, ठीक है ना? चारों को देख के प्रॉपर रीजन आइडेंटिफाई करना है. Okay? So this is our region. Yes. Are you with me?
Yes, sir.
Yes, sir.
So this is our region, right? So now our x limit is constant and y limit is variable. Now we need to change the x limit. So how we change the x limit? We'll put a horizontal line or a vertical line. Tell me.
Horizontal.
Yes, horizontal line. So let me put that horizontal line over there. So can you mark the entrance and exit? Yes.
सर y
Can
इक्वल
you-
टू
Sir, y equals to 0.
जीरो वाली लाइन
यहाँ से यहाँ
एंड
तक.
x इक्वल टू y.
ट्रू? इज इट ओके? ठीक है.
Yes, sir.
तो
Yes, sir.
अब यहां से x की वैल्यूज निकाल लो. यहां से तो x है ही 0 और ये कौन सी लाइन है? y इज इक्वल टू x वाली. तो यहाँ पे x की वैल्यू क्या आ गई? y आ गई. हाँ, और y की कांस्टेंट लिमिट लेनी है. तो y कहां से कहां तक रन कर रहा है पूरे रीजन के लिए? 0 से लेके pi. Yes. Is it fine?
Yes, sir.
So should I write it? So I'll write it as x रन कर रहा है, सॉरी y रन कर रहा है 0 से लेके pi तक और x रन कर रहा है 0 से लेके y तक. अच्छा, अब मेरे को ये बात बताओ कि what is the use of that? Now, of course I have changed. See, always keep in mind, जब भी क्वेश्चन करोगे और चेंज कर लोगे तो ये dy dx जो है that should get converted and should be in the form of dx dy. Now, can you tell me कि what is the benefit of doing this?
साइन में
Anybody?
बाबा इंटीग्रेबल नहीं था.
हाँ, that is the thing, because here we used to have a complex integrand that was little complex. We were not able to do it. Yes? Yes or no?
Yes, sir.
Okay, so let me put it in that way. So this is 0 to pi. Now this will be easy to use. Why? Because now whole y will become constant. So now you can write it as sine y upon y times the x, and limit of integration would be x from 0 to x is equal to y. Yeah, right? Yes, tell me.
Yes, sir.
Yes,
So
sir.
now you put the upper limit first. So this will become what? Sine y by y into y minus. Now you put 0, that will become 0 dy. So that would be minus cos y and 0 to pi. Okay, so minus cos pi minus cos 0, right? So it will become 2. Yeah, you're with me?
Yes, sir.
Yes, sir.
Okay, are you getting the points? Tell me.
Yes, sir.
So let's say question number 24th. Okay. Okay, so given that is 0, 1, again, we'll need to change the order of that integration. 1 minus x to 1 minus x square. Okay, dy dx. So here we have f of xy to be 1 only, right? We don't care about that. We are, most of the time in these questions, we are more interested in the limits rather than the function itself. Okay. So can you mark those limits? So this is y, this is again y, this is x, and this is also x. Yes. Is it right?
Yes, sir.
Yes, sir.
Now what happens? We need to construct the reason first, right? So yes. So this is there. So first of all, you take care of your region. So x is equal to 0 and x is equal to 1 are what? Are lines parallel to the x-axis. Yes, right? Sorry, y-axis.
Parallel to y.
Yeah. So this is your x is equal to 0 and this is your x is equal to 1. Yes, you're with me?
Yes, sir.
Yes, sir.
Now, we want to find out this. That means this is a line which becomes x plus y is equal to 1. So that means it is in the intercept form. Okay?
Yes, sir.
Yes, right? Let me increase the length of this axis. Yeah. So this is almost 1 over here. And this is also our 1. So this is 1, 0. And this is 0, 1. So the equation of the line, I mean, we are plotting that line. So that line will become this. Okay? X plus y is equal to 1. Yes. You're with me?
Yes, sir.
Yeah, that's it. Right. And the next part is we have y is equal to 1 minus x square. So that means y is equal to 1 minus x square. So that means x square is equal to 1 minus y, or in other words, x square is equal to minus y minus 1. Yes. Am I right?
Downward
Downward parabola, vertex kahan pe?
0, 1.
0,1.
Yes, yes. So x square is equal to minus y minus 1. So this is the vertex, right? Now mark the points carefully where it cuts the x-axis as well. So it will cut the x-axis when your y is 0. So if your y is 0, so this becomes x square. Let me solve first over here. X square minus 0 minus 1. So x square is equal to 1. So x is equal to plus minus 1. Right? Yes. Are you getting this?
Yes, sir.
Yes,
So
sir.
that means it will cut
Yes,
the
sir.
x-axis where x is either plus 1 or minus 1. Yeah, you are with me?
Yes, sir.
So that means, let's say we mark the point over here at a same distance, minus 1, 0. And this is your 1, 0. And let me draw that parabola. And this is your parabola. Yeah, right? So what should be the reason? Tell me.
Sir, line or parabola के बीच वाला.
Yes, sir.
Yes.
Line
yes.
or parabola.
Again, this will help you in telling this, because we are starting from the line and we are ending at the parabola. So of course, y ranges from line to parabola, and your x is lying between 0 and 1. So of course, the enclosed region we have is this much. Right? You're with me? Tell me.
Yes, sir.
Yes, sir.
So now we are only having the limits of y, right? So now we want to convert the variable limits x in terms of y. So what should we gonna do? We'll throw a horizontal line or a vertical line. Tell me.
Horizontal.
Yes. So if dy is there, that means the vertical line has already been thrown. So you want to take dx over here. That means you need to throw a horizontal line into the region. So from here, every time you check it. Okay. So now, so what is the entering limit of x?
1
Line.
minus y.
See, you take x over here, you take y over here. So that means your x is what? 1 minus y. Because you'll take the limits of x from straight line, because your entering point is straight line, right?
Yes, sir.
Yes, sir.
And your exit point is parabola. So you take the value of x, that means the upper limit, from parabola. So from parabola, what could be it?
Root 1 minus 1.
Yes, root y minus 1. Yeah. Sorry,
One.
root 1 minus y. Yeah, that's fine. So now, y is varying from here to here.
0 to 1.
Yes, so you will
Yes,
take
sir.
the constant stretch of y. So that means your question would be get changed y0 to y1, and your x is 1 minus y to 1 minus root y dx dy. Okay. Yeah, true. Tell
एक्सक्यूज मी
me.
सर
बोलो.
सर मतलब जब भी हमें जैसे इसमें y कांस्टेंट पुट करना था तो x की जो लिमिट थी 0 to 1 वो हम डायरेक्टली y में पुट कर देंगे.
यस यस,
ओके सर.
ठीक है, वो वहां से डायरेक्ट निकलेगी. ठीक है. कई बार क्वेश्चन थोड़ा कॉम्प्लेक्स हो जाता है, दो रीजन बट जाते हैं. जब दो रीजन बट जाते हैं तो केयरफुली उसे देखना पड़ता है कि x कहां से कहां तक आ रहा है, y कहां से कहां तक आ रहा है, एंड सो ऑन. ओके. तो
सर मतलब जब भी कांस्टेंट हो तो हम डायरेक्ट पुट कर सकते हैं मतलब ग्राफ में
कांस्टेंट
ड्रॉ
होता
करने
तो
के.
प्रॉब्लम ही नहीं है ना, फिर तो हो ही जाता है, फिर कोई प्रॉब्लम नहीं.
ओके सर. ओके सर.
तो लेट्स से वी हैव सम dx माइनस dx dy हमारे पास हो, हम dy dx करें, ऐसा क्वेश्चन हम करके देखते हैं. ठीक है. या यू आर विद मी?
Yes.
Yes, sir.
Yes, sir.
Okay, so let's say this question is there, question number 26. Okay, so your ln2, your favorite ln2 is there, and sorry, I've written the limits from another question. Okay, so 0 to ln2 and ey to 2. Yes, so these are the limits of what? X or y? Yes, x. And these are the limits of y. So that means dx is already there, and we want to replace this dx by dy. So of course we're gonna throw this time a vertical line. Okay, so first of all we'll construct the region and then we'll do the question. So let's construct the region, and this would be the probably last question of this session. Okay, so y runs from 0. So this is a line would be parallel to the x-axis. So y runs from 0 to log 2 to log 2, let's say somewhere here. Okay, so this is your y is equal to ln 2, and next is x is equal to ey. So from here your y is ln x. So this is your y ln 2. So let me mark this thing over here. Why? Because if you put x is equal to 2, so your y would be what? ln 2. तो यहाँ पे यहाँ से यहाँ तक ही आएगी ना ln 2. आई मीन log 1 क्या होता है? 0 होता है ना log 1. तो ऐसे ही जाएगा और ऐसे जाएगा. ठीक है. इज इट फाइन? समझ
Yes,
आ रहा
sir.
है? बोलो.
सर
ठीक है.
समझ नहीं आया.
हाँ बोलो, क्या कह रहे हो?
सर ln x वाला.
हाँ, मैं पूरी लिमिट्स एक्सप्लेन करता हूँ. देखो, एक है तुम्हारे पास y0, एक है y ln 2. ठीक है. एंड नेक्स्ट यू हैव टू थिंग्स, x इज इक्वल टू 2. ठीक है. और एक है x इज इक्वल टू ey. तो ड्रॉ करते टाइम पहले इसको प्रॉपर फॉर्म में तो लाओगे ही. तो यहां से y क्या बन जाएगा? ln x बनेगा.
यस सर.
अब अगर तुमने x को 2 पुट कर दिया तो y की वैल्यू क्या आ जाएगी? ln 2.
यस सर.
ये x2 है ना तुम्हारा, तो ये वाला पॉइंट क्या बना तुम्हारा? 2 ln 2. ठीक है.
यस सर.
तो ये 2 ln 2 इस लाइन पे, सॉरी इस कर्व पे भी तो लाई करेगा ना.
यस सर.
तो इसीलिए मैंने ये वाली कर्व इस पॉइंट से पास करवाई ना. ठीक है.
ओके सर.
ये वाली कर्व इसीलिए इस पॉइंट से पास करी ना. तुम सोचो अगर ये ऊपर नीचे हो जाती तो पूरा रीजन बिगड़ जाता ना. अगर इस तरह हो जाती तो रीजन अलग बनता, इस तरह हो जाती ये कर्व तो रीजन अलग बनता, इधर या इधर. इज इट फाइन? यस, टेल मी.
Yes, sir.
यस सर.
So we have to be very careful in constructing that region. Now this is your region, right? So now you want to keep your x constant. Okay, so can you tell me what is this point? ये पॉइंट क्या है?
1.
Tell me.
1,0.
1,0. Yes. So this is your region. Just yeah. Is it true? This is your region.
Yes, sir.
Yes, sir.
Now you want to replace it with dy dx. That means you need to put a vertical line into that. Okay. So can you mark those limits now from here to here? So what is the entering point of y?
Right.
Huh? Entering point of y. Can anybody tell me?
Sir, y equals to 0.
Y
Yes.
is equal to 0.
And 2 y is equal to 0. जा कहां तक रहा?
Y equal to ln x, log x.
Log x, ln x. Right? And what are the limits of x? Constant stretch, max and min. I mean min and max.
1 to 2.
1 to 2.
Yes.
1 to 2.
1 to 2. That's it. Okay. So one of the limit will always be constant, and that you choose like minimum to maximum. That's it. Okay. So x is equal to 1 to x is equal to 2. Right? Are you with me on this?
Yes, sir.
sir एक doubt है.
Just a minute. Just wait for a minute. Now there is no function. Okay. So there will be no function. You keep it as dy dx. That's it. So you are done. अब पूछो डाउट. क्या डाउट है?
सर इसमें हमने वो जो ln 2 वाली लाइन थी उसको ln x से लाइक पास करा दिया उन दोनों को. सर
हाँ.
अगर यहाँ पे ln 2 की जगह ln 3 होता तो भी यही
तो फिर नहीं. तो कई बार ऐसा हो जाता है. I'll explain that part. अब कुछ ऐसी एग्जांपल भी आ सकती है. Let's say this. तो ऐसा भी हो सकता है. जैसे ये. Let me tell you. ये और ये. ओके. तो अब तुम ध्यान दो. ये है तुम्हारा. Let me mark with a different color. देखो. ये आ गया. And there is a red line. Yes. So let me mark this red line as gx and green line as fx. तो अब देखो. अब अगर हम if you throw a vertical line, what will happen? Can anybody tell me?
2 regions आ जाएंगे.
Yes, there are 2 regions now. Okay. तो अब क्या है? Regions तो 2 हैं. लेकिन you see that in first region your entering is at red curve, right? And exit is at green curve. Yeah. True?
yes sir.
Yes,
For first region. But after this point, the things got flipped. Okay. Now your entering is at green point and your exit is at red point. Yes. Is it fine?
yes sir.
तो वो ऐसी सिचुएशन बन जाती अगर ऊपर नीचे होता तो. You got my point?
yes sir, got it.
ठीक है. तो वो इस तरह की सिचुएशन बन सकती है कि देयर आर डिफरेंट एंडिंग एंड एग्जिटिंग दैट यू नीड टू ब्रेक इट. तो यहां से वो ब्रेक हो जाएगा फिर. ठीक है ना. यहां के लिए अलग, पहले रीजन के लिए अलग लिमिट्स, दूसरे के लिए अलग. सो दिस विल बी ट्रीटेड अ डिफरेंट रीजन, राइट? एंड आफ्टर अ ब्रेक दिस विल बी ट्रीटेड एज अ डिफरेंट रीजन.
सर तो वो एडिशन में
एग्जैक्टली वो एडिशन में लिखा जाएगा.
ओके सर.
ठीक है. यस. यू वांट
Yes,
टू आस्क
sir.
समथिंग?
सर एक बार ये वाला पार्ट फिर से रिपीट कर सकते हो सर?
बिल्कुल, क्यों नहीं. बोलो क्या पूछना चाह रहे हो.
सर लाइक आपने बताया कि दोनों में अलग अलग एंटरिंग पॉइंट्स हैं उसके बाद.
हाँ. तो लेट्स से आई विल गिव यू अ हिंट. लेट मी पुट इट टू द नेक्स्ट पेज सो दैट आई कैन मेक द थिंग्स क्लियर. So I'm considering 2 scenarios. So let's say if you take the limits from here, let's mark the limit. Let's say from here from here to here. Okay, so this is your x is equal to a, and this is your x is equal to b. Now you see that your entering limit is at red curve, which was gx. So let's write again, y is equal to gx, y is equal to gx is our red curve, green is y is equal to fx. So y is equal to fx. So now you know that if, let's say, you are considering the area in the both cases above the x-axis, so let's say we'll also restrict our area bounded by the x greater than equal to 0. So we are left with this area and this area. But you see that there are actually 3 splits of this problem. So let me mark those things. So you see this, your one split is here, right? That means from here to here, and then you start your y from here to here. Okay, so if you see in the first part, this is your first part, and this is your second part, and this is your third part. So if you see in the first part and you throw a vertical line into this, then you will come to know that your entering point is here. Why? Because we are considering x is equal to 0. I mean x greater than equal to 0. And exit is at green curve. But as this constant part ends, you see this constant part, this ends at this point, then your y starts from the red curve, right? So this was our red curve. So let me mark it again. So this used to be our red curve, right? This way. So here, if you throw a vertical line into this, so let's say this, then your entering point at red curve and exit at green curve. But this is a point of flip. Here the things got flipped. Your red curve is now a higher curve, and here your green curve is a lower curve. So your entering is here and exit at here, right? So you need to carefully mark your flipping points where the behavior got changed. So if you see this, so this is your flipping point, flip, and one flip arise over here, right? So in this case, so let's say you call it as C and you call it as C dash. So now x from A to xc, this is your A and this is your C, and y you take 0 to green curve. So y is equal to 0 to green curve. That means fx, some function over here, right? dy dx, okay, plus yes, yes. So plus, now from C to C dash, this is your C dash. So from C to C dash, what is your y? Your y starts from this red curve and ends at the green curve. So that means your y starts from y is equal to gx, red curve, right? And to y is equal to fx, our green curve. So function which will be given to us dy dx, right? And plus, so one more expression we'll be needing over here. So let's pick this thing to the next page. So we'll discuss the second case over here. So now plus if you take C dash to B and your y starts from the green curve to the red curve, because in this case the things have flipped. So our lower limit is at green curve, which is y is equal to fx, and upper limit is at red curve, which is y is equal to gx. So some function dy by dx. So that's how we'll calculate those limits when we have this kind of setup. Now we may have a second kind of setup where let's say we start from x is equal to a to x is equal to b. Now in this scenario we'll have only one flipped point, which is at here, to call it as c. So now if you start from a to c and then your lower limit will be from here to here, that means red to the green, that means gx to the fx and dy dx plus. Now of course, now this is your flipping point, things have flipped over here, so we have just one flip point in this scenario. So this is x is equal to c to x is equal to b, and your y runs from green to red, so that means y is equal to fx to y is equal to gx dy dx. There will be some function, if it is there then we'll calculate it. That's how we calculate the limit over these kind of regions.